Great. So yeah, my name is Erasmo Cadena. As Julia mentioned, I'm from Ghent University in Belgium. And now I will move into the last part. I hope you are still with me in this last session, which is related to the lifecycle assessment methodology and some applications. So the contents in where I divide this session is in 5 main blocks. I will start with some objectives that we will get, what kind of knowledge we get at the end of the session. And then we submerge into the LCA methodology itself. I mentioned some story about this methodology. What is the concept about? What are the 4 main stages or steps that we need to follow to properly apply this methodology? And finally, we see some real case study based in some publication of the steel production in Italy. So starting with the first point, which is the objective. So what we will have at the end, as Julia mentioned as well. So this is related with the sustainability aspects, but in the LCA is more focused in the environmental part. So in this kind of pillar, and in here we learn for sure what would be the concept about that. Probably some of you already know it or heard about it. Secondly, we go through all the different steps that we need to follow, and also to identify kind of challenges and limitations that this tool can present when we are applying to certain project or product. And at the end, we see this application of the tool in the real case study that I mentioned it before. So the level of knowledge that we have at the end, so the LCA can be divided in 5 levels. And after this session, it would be have basic knowledge, so about the concept and some really easy application, but it will be the base for you if you want to after continue learn more about the methodology, and you can for sure increasing in time until you can be able to apply and be some LCA practitioner. So now moving into the subject, to the LCA itself. So in here, I'd include some diagram of the evolution of this methodology. Nowadays, probably you hear about a lot about the environmental impacts. So there are many people interested in the governments as well, or even people with a lot of power like Bill Gates. They are published some recently a book about the climate change. But this is something in terms of the methodology wise that is starting not now, it was like a few decades ago. And actually was in the early 60s in where big companies like Coca-Cola, they were start making some analysis of the products that they are having in the factory, because they want to analyze in one hand the energy that I use, and in the other there is the residues of the wastes that they are generated. Not because they want to focus into the reduction of the carbon footprint or the environmental aspects itself, but because they want to reduce the money that they are spent and also to be properly use the resources that they have internally. But after that, so were other companies, other research centers that were also interested in these topics. That's why in the 70s and the 80s, it was a lot of people interested. It was journals that published some studies related to this subject, also conferences. But they discovered at a certain point that it was not following the same steps, so it was not really harmonized. And it was in the 90s in where the ISO standards say, well, I think it would be better if we define some steps that we need to follow all together. And no matter if we are making Europe, Asia, and America, so we can have kind of similar results that we can compare afterwards. Then it will be more efficient for everybody to have this knowledge, because so far we are following methodologies that probably are not the same and we are not consider or taking into account the same things. So that's why after the 90s, it was more evolution, everything was harmonized, and all the papers that you see now in the literature are based in this ISO standard. And for sure now they are more interested not only in the classical way, but is more applied in different sectors that I will show you in the next slide. And here we can see again the evolution. So as I mentioned it before, so in the 60s, it was starting, was not a lot of publications, but after 90s, when everything was more harmonized or standardized, was more increasing in the publications. And in terms of the countries that were more into this subject is the US, and we're starting this kind of movement. And after was a big push in the last years, probably after the 20s in China. And as you can see in this graph, the rest are countries in Europe, and actually Italy is in one of the tops. They make more publications in this subject. And the application, so it can be in different areas, from environmental engineering for sure, but it can be also materials, chemical, agriculture, biochemistry, and many others. So you will see that it's really diverse. So if we move, where is the concept of the LCA? So maybe, as I said before, maybe you hear about it, or probably you are working or you are interested in this, but where is the concept exactly? So in here I include some definition that actually is including everything about the LCA. And I will read it literally. There is the evaluation of the environmental borders associated with some product, process, or activity in where we are able to identify or quantify the energy and material that were used since the extraction of the raw materials, some manufacturing, and after transport, use life, and end of life as well. So in this case, we are including all the different steps, and we identify all the different impact, all the different input and outputs that we have it. For sure, as we can see here, every step in the life cycle, it's another life cycle itself. So that's why it can be really complex. Depends of the limits that we define it for our analysis. Okay, so I think now it's time for moving into the 4 steps in where we devote more time for the talk today. And in here, this is the 4 main steps that was defined for the ISO 40040. So you want to check more, you have the reference in here, but they are include 4 main blocks. So first, starting with the goal and scope definition, after moving to the lifecycle inventory analysis. And the third point, it will be to make the impact assessment and finally make some interpretation. As you can see in here, there can be iterative process. So it doesn't mean that if you finish something, the analysis is done. So you can make some adjustments and go back to the first step, second or third one. So this is another thing that is iterative process that we can have. So now we see one by one because it's not enough with that. So starting with the goal and scope definition, in here is in where we need to, for sure, define why we want to do this analysis, in which will be our audience. So this is really important in order to delimit the system boundaries that we will take into account, because the analysis in terms of lifecycle assessment will be as short or as bigger as we want. So that's why we need really define what will be the audience. It will be, for example, for internally reasons, because we want to improve some aspects in the value chains that we have it. So we want to focus in where we have the highest impact and where we have more losses, for example. This is one of all the scope that we have it. But also can be externally, because we want to communicate the results and compare against the other similar processes that are in the market. And that's why our audience will be more abroad, more big. That's why we need to define exactly since the beginning what will be our purpose of that. And as I mentioned, we also need to define the system boundaries that will be really relevant, because we included all the steps that we want to analyze, or in where we want to focus, and also the functional unit. So because the functional unit will be the basis for making the comparison against different systems. So I will show you some example in here. Where's the functional unit? In this case, we need to reply to different questions like what, how much, what, for how long, where, and how well we need it. So this is really precise functional unit. In some cases, we don't need to go making a lot of details as in this case, but it's I mentioned this just for you to have an illustration of what is the functional unit. Again, the functional unit is something that we need to use for compare. For example, in the case of the outdoor paint, where is the main objective? Where is the function that they have it? So for the painting is to cover certain surface, can be in square meters. And that's why we use, so we consider the coverage complete of 1 square meter in outdoor per 10 years in Germany, with some uniformity of the color in 99.9% opacity. So for sure, in some cases, we don't need to be that precise, and we can include more type of paints, but we want exactly this kind of characteristics. So we only can compare these paints with these specifications. That's why in here we are avoiding to compare pears with apples. If we compare always pear with pears and not make them mix and many things. In the case of we want to compare different types of grocery bags, so they can be in plastic or paper. And in this case, the function of the bag itself, it would be to carry certain amount of products. In this case, we can define a functional unit as some grocery bags, even if it's in plastic or paper, but they can carry 10 kilograms or identical goods. So they can be one or functional unit. And finally, in terms of some process like wastewater treatment or solid waste or recycling technologies, so in here we can take into account two different approaches. From the materials that are entering, so the capacity of treated 1 square meter of wastewater in this case, or 1 ton of solid waste that enter in the plant. This can be our functional unit or can be the output. In this case, it will be 1 square meter or water treated with certain characteristics or quality of the water, or it can be the production of compost or production of 1 kilogram of metal recycled in the plant. So that's why we need to define exactly, and we need to see against we want to compare and define properly the functional unit. Now move back into the system boundaries, as I mentioned. So it's really important to define what kind of steps we will take into account. So it can be as bigger as we want, for example, taken from the cradle to the grave, which is from the raw materials extraction until the end of life, or even can be cradle to cradle in where there can be some output that can go back as a raw materials in the same value chain. So this is like cradle to cradle, but more of the time in where the use phase probably is not representing really highest impacts, or it can be similar impacts because the use phase it will be really the same. So we can focus in this part, which is called cradle to gating, where we have it from the extraction of the materials until the manufacturing, and here we have the final product. But after we don't look into the use phase, or we can even extend until the end of life, in where we can model different end of life scenarios that we go to the landfilling, incineration, or even some recycling and reusing of the material. So this is like the system boundaries that we can take into account. So now we properly define the functional unit at the system boundaries, and we know our goal or our objective of the study. So we move into the next step, which is the lifecycle inventory. In here is essentially to collect all the data from the mass and energy balances, all the input and outputs that we have in the system that we defined it before. So it would be better if we make this illustration in here. We can see we have the production of this product A, and for this we need some certain quantities of materials, energy, and water. And where we have it, besides the production of A, we have also emissions to the air, emissions to the water and soil. And all the information that we have in here, all the steps and the items, input and outputs that we can collect in here is called the foreground system. But we can also have another information that is really relevant, for example, to produce this material, to produce this electricity, and to produce this water that we needed in the process. So for sure, this is another type of impacts that is called background system. And for sure, we need to take it into account as well. If we consider this, it will be the cradle to gate approach. Okay, so this is actually one point. So in here it's really easy. We have only one output, but what happens if we have different outputs? So for sure, we need to make some allocation or division of the impacts among the two different outputs. The ISO standard actually say that it's not really recommended to have this separation or allocation of the impacts, because it's probably in some cases not really proper done. But if it's not possible to avoid because you have anyway one product and different byproducts, you need to make the allocation. In that case, they're recommended to make the economical allocation. For example, in this case, it's really easy because the main product, which is the most important for us, is like highest value in terms of economic compared to the rest. But what happened with the contrary? Probably here we have no. That's why they recommended the economical. Sorry, but the mass allocation is not really recommended because in some cases, even though we are producing really small amount in the product A, but it's just or most important because we get more money. But in this case, probably can be a lot of a quantity, but it's really small money. That's why in this case, it's always recommended the economical evaluation. But if we have, as in this case, in where the product A have more quantity, probably we can also use the mass allocation. Here's another examples that we can use. In the case of the subdivision, so we can see here there's no interaction between product A and product B, so we just simply split it and consider this as a one line, this and the other, but don't make any allocation. It's not needed. In this case, is the example that I show in here. So make some partitioning in terms of economics, so the mass allocation. And finally, it's another one that is called substitutioning, where we have some main byproduct and we have some other product that is not really important for us, but it can be something that can be introduced in other process. And in that reason, You are avoiding the impacts to produce this material that can be applied in the process too, for example. And that's why you are avoiding to use virgin materials to produce that product that is needed in your production line, but you are avoiding to produce it from zero because you have it in another process. You just make the substitution in here. Okay, so again, go back to the foreground and system and the background system information. In the foreground, as I mentioned, so it's in where we have the capacity to make measurements, also asking to the people that are working in the line or making some assumptions, some modeling, because we have the capacity of make it. We are having the control. But with all the other information that can be emissions to the transport, the electricity generation, materials, chemicals, etc., that we needed in here, so for sure, we can make our own analysis, but it will be really complex to go back and get this information. And as in here, we can find different databases that are already created for in the market. They are really well evaluated for industrial partners, and we can find it in equipment, for example, agriculture, agri-footprint is another database that you can find related to agriculture for sure, and it's another provided by Gabi. And in here, so we can find a lot of industrial processes, for example, for production of tap water or electricity in Italy, for instance, or even for the transport of certain material by using certain type of fuel. So we can use the databases and we don't need to make this analysis for specific things. So I think where we're avoiding time in not replying this kind of analysis. But anyway, in this stage is in where we devote more time, because in where we need to collect data, we need to make some assumptions. We need to, well, probably go to the site, or essentially go to the site, and then to select properly the databases that we needed to be more accurate with the system that we are analyzing. So that's why we need a lot of time, validations, and so on. But after we have all this information, we can move into the next step, which is the impact assessment. And here is in where all this input and outputs, all these emissions to the air, soil, and water, that are transformed into impact categories. So there are all these flows that I mentioned before, they're called elementary flows. Thereafter, they would be multiplied by certain characterization factors in order to have some results that, for instance, can be the climate change or the carbon footprint indicator. So it will be more easy. We see in some examples in here. So as I mentioned, so all the elementary flows are transformed in some impacts that can be climate change, but also this is the more common or well-known, but there is many others, land use, acidification, many others. And here the part that can be affected in the environmental can be some of them like climate change affecting the human health, but there be another that is only more related to the natural environmental or natural resources use, like land use, for example. And here is again the same example that I mentioned it before. So for the production of product A, so we have a certain amount of emissions to the air, and also in here. So if we want to analyze this really known category or impact indicator, that is climate change, that is represented in kilograms of CO2 equivalent, we need to make some calculations by considering the characterization factors that I mentioned it before. So because everything is based in the CO2 emissions, so 1 kilogram of CO2 is equivalent to 1 kilogram of CO2. But in the case of methane or nitrous oxide, there are other characterization factors because it's really more polluted compared to CO2. In the case of methane, it's 28. In the case of the N2O, is 265 kilograms per 1 kilogram of N2O. So, and basically, what we need to do is make the multiplication of the amount that we have it, of this amount that we collected into the inventory in the previous step, and then multiplying by the characterization factor to have some results. So we have in here for our foreground analysis or foreground system, but also we consider all the impacts that we collected in the background by using the different databases. And then at the end, so we just need to make the addition of the thing, and we have the result in terms of climate change of this certain amount of kilograms of CO2 equivalent. Okay, for this, we don't need to make it by hand. Actually, there are some softwares like a really popular CIMA Pro or Gabi, in where you have the database itself, so you can go there and check with the databases that are available for making your analysis. And after, you can choose the methods in where you can find the different indicators like climate change, acidification, and many others. and you just need to choose the method, and then it will be all these arithmetic things. It will be done directly by the software. For sure, the softwares are not for free. There are certain amounts of money, so it's kind of expensive, but it's because of the databases that are included in the software. There are some, like it's called OpenLCA, that is for free. But the thing here is like it's for free, the platform, but the databases are not included, so you need to import it. That's why anyway you need to pay for the databases that you want to use that are not available in the software. Okay, so after we make this, we obtain the results, and in the indicators that we selected, so we have some, we need to make some interpretations of that result. So we need to extract some conclusions to identify, for example, in where we have the highest impact, and then try to identify why, which were the hot spots in that specific steps. And then we can also make some sensitivity analysis by modifying some parameter and make some assumptions. For example, can be like electricity is really relevant, so we can change according to different types of electricity mix, for example. And there is also another possibility to make uncertainty analysis, because some data that are come from the databases, they can be also not really precise. So we need to make some analysis as well in terms of the quality. And as I said before, so after we have this first interpretation, we can go back and check, maybe we need to adjust our functional unit, or probably we need to extend the system boundaries because we are not fair in the analysis, or we need to check the quality of the data, or we need to change the method because probably it's really obsolete or is not the one that we want to take into account for make the comparison. Okay, so I hope with this quite briefly introduction of the methodology was kind of clear, but now we move into the example that I think would more relevant for you to have it like a real case study. In here we choose this publication that actually it's open access. You can find it online. So it's the life cycle assessment of steel produced in Italy and in the integrated steel mill. Was published in 2016. And in here, the purpose was to analyze in the really extensive way all the different environmental impacts they have it in some real plant that maybe you know that is located in South Italy, in Taranto. That is really known because there are a lot of pollution and some conflicts with the people or population that live close to the area. So that's why there were some researchers that want to make the analysis and to see where they can improve something. So that's why the goal in there was to analyze the main hotspots in that industry, and also to identifying which parts they can improve the environmental performance. In this case, the functional unit that they take into account was the production of 1 million tons of solid steel slabs, because this is one of the main outputs that they have in the industry, and they take this into account. And in terms of the system boundaries, they say, well, we delimit only in the manufacturing of this material. So they consider 4 main steps: the coke oven, sintering plant, the blast furnace, and the final production for casting and blast oxygen furnace. And in here, as I mentioned before, so it was the cradle to casting plant gate. So cradle to gate. After with the use phase, or after with the transformation of these steel slabs, was not taken into account, or not the end of life of these materials. It was the out of the system boundaries. Okay, now that everything was defined, the system boundaries in the functional unit, we move into the inventory analysis. In here, I will show you only one example of one of the steps, so the units that was considered for the analysis, which is the coke ovens. And you can see all the input and outputs that they have it, as I mentioned before. It's in this case, so for the inputs, they needed some coal, some sulfuric acid, water, sodium hydroxide, but also vapor and electricity that's going in this process. And after, we have some emissions to the air and some emissions to the water. And also we have some byproducts like tar or ammonium sulfide. And the final, or the main output in this process is the cokes plus coke dust that go into the next step, that would be the sintering plant, and so on. So, but I will not show you the rest of the steps. Well, after making this inventory analysis, they use the CIMA Pro software 8.0 and also the incumbent databases, in where they found it a lot of of the of the items for making the analysis, and they choose some methodology called recipe, in where they're included the different, all these different impact categories. It's included the climate change, but also that many others related to the acidification, particulate matter, and so on, land use as well. And in here, so we can see, according to these results, that in gray and also in blue, they were the two steps in where they found it the highest impacts. It was in the coke oven and also the blast furnace. And the reason was because internally they use some transport for the material from one unit to the other, and also for the energy use that was really intensive in these steps. They also analyze the potential contribution of the human toxicity that can affect directly in the area surrounding Taranto. So that's why they want to know exactly in which units have the highest emissions that can be affected to the population. And in this case, they use the same software, same system boundaries and functional unit, but they use another method that is called USTOX, in where they can calculate the toxicity itself. And in here, they identify that the Sinteris plant is in where they have highest repercussions, because they have a lot of emissions for heavy metals, dioxide, and polychlorinate, dibenzonate, that can affect it directly to the health of the people, and also have some repercussions in terms of the cancer effects. Okay, so the final step, and actually is my last slide in the presentation, is the interpretation of the conclusions that they extract from all this analysis. So they identify, for example, that some slag that they produce, they can be useful or can be used as a byproduct in the infrastructure or in agricultural purposes. That's why they say, well, if currently they are not using as a byproduct, they are not selling or using in other purposes. We are selling for landfilling or other type of stabilization, so we are not taking advantage of that. But now we can identify that that material can be useful as a raw material for other processes like agriculture. And that's why we are making this substitution or reducing the environmental impacts in our process in general terms. They also identified that the results in terms of energy needed for the different process or in general in the plant was higher compared to other studies that they can found in the literature. That's why, even though they were not really into detail, they say, well, it's something that we need to put more attention, because it's not possible, or why it's possible that we have more energy needed compared to the others. So there's something where we are facing losses, or we need to save energy in order to be like at least similar to the other steel industries in the market. The other point that actually I mentioned before is in the blast furnace and the coke oven, in where they have highest impact in all the categories that we're analyzing. And finally, they also mentioned some limitations of the study, because they say, well, we included from cradle to gate, but only until the slab steel production, but not for other semi-final products that can be for the rolling or other materials that can be also produced in the steel factory. And that's why they cannot compare the analysis with the other, in where they include that part. So they say maybe we need to extend the system boundaries in order to include that part as well, and to see if that part have also highest impact, and also to see if we can reduce the impacts in that part. So this is mainly the 4 main conclusions that they can extract from that. And that's pretty much it from my side. So if we have some questions, we'll be happy to reply.